Good morning, good afternoon, or good evening, wherever you may be. Welcome to today's session by RAK Wireless, IoT made easy with WisBlock. I'm José Marcelino, Solutions Architect, and I'll later be joined by Maria Hernandez, our Developer Relations Lead. In today's session, we'll be looking at the new and exciting WisBlock, our development kit for nodes. Then Maria will lead a practical workshop where she'll explore a real-world application of WisBlock. Finally, we have some slides on how to set up WisBlock so you can also deploy the application yourself. So why did RAK Wireless develop WisBlock? Well, we took inspiration from the most flexible stage of any IoT project, the proof of concept. At this stage, everything is possible. Developers use common blocks such as development kits, sensors, and power supplies, and they wire them together with wires and breadboards. This allows the developer to add, remove, or change any component in the system very easily. However, this is not a good solution to test because it's messy, so you'll have to find a client who will accept that you install this at their site. And also, it's very fragile. So if a wire comes loose, you might not know if the problem is with the wire being loose or if there's some other issue with the system. However, the flexibility is really important because often at this stage, you don't know what all the requirements are. And this is what WisBlock allows you to do. So you can take this flexibility across all stages of an IoT project. Continuing the traditional IoT development path, we now reach the prototype stage. At this stage, the developer is interested for results, if the device is working properly, and also to refine the design before going into manufacturing. At this stage, the developer usually either creates or commissions a custom PCB for the device where parts can now be soldered. So it's all much more solid. Usually it also involves some 3D printed enclosures for this device. So in the end, they will have a device which they can give away to more clients who will be willing to try rather than the proof of concept. However, all the hardware that has been used in the proof of concept is now useless because they will need different hardware. Also, this comes at the cost of flexibility because since parts are now soldered, it's much more difficult to change anything on the system. You'll have to rework, add some very tiny wires, and maybe even sometimes it's just not possible. Imagine just getting the RX and TX wrong, which is such a common problem. This is what WisBlock tries to avoid. So with WisBlock, you use the same hardware in your proof of concept as in your prototype stage. You just make more of them and give them to more customers. It's really simple. Then finally, we reach the production stage. Hopefully, you'll have enough results to show that the device is working correctly and that you have a design that can be manufacturing. This often involves small changes to the design, such as panelization at least, so that they can be produced in scale. So it also means that you will be going into certification soon. So if there are any problems with your custom boards, which generate, for example, excessive EMI, then you might fail those certifications and you need to redesign the hardware again. Again, this is what WisBlock tries to avoid because all the parts in WisBlock have been tested. So we know that they will work correctly and not exceed the legal limits. So just to recap what I've just said, here we have two paths. So there is the typical hardware path involving custom PCBs and soldered parts. And there is this new agile path with WisBlock where you can still change the hardware all along up to production stage very easily and even beyond after deployment. So let's look at the typical cycle. This is called the waterfall model. Essentially, it's very well known in software. So you start with the requirements, then you design hardware that meets the requirements. You implement it with the software, you run it to several verification stages, and then hopefully you reach a solid device which will just need maintenance. However, this is very idealized. I've never seen an IoT project working like this personally. I think IoT projects tend to be very flexible, so you don't know all the requirements up front usually. You'll only find them after you do a few trials with hardware. And by then, you might have gone through, if you're using a traditional model, you might have gone through several designs for your hardware, which is very costly and also wasteful. So with WisBlock, you avoid that because all the components are modular. You can just change them anytime you need. So if the requirements change, you just change the hardware. It's really simple. So let's look at WisBlock. Our motto is click, code, and connect. This shows how easy it is. You just get the modules you want, you click them onto the baseboard, you start up your Arduino or Platform I/O, and more supported very soon, and then you're ready to connect your IoT application to the most popular IoT networks, which are LoRa and cellular. We even provide you with a very nice kit, including all the modules you want, and a screwdriver just to secure down everything so you can go into production right away. The WisBlock system contains the base unit. This is our baseboard, the standard baseboard. Then we add the core module. This includes the microcontroller and the radio transceiver. In our case, we're currently using the Nordic NRF 52840 and the latest from Semtech, the SX1262 transceiver. We do have more options for the core, so we'll have a core for the STM32WL very soon, and that's the beauty of WisBlock. If you're not happy with the performance of one core, you can just change it. You can even change it after the device has been deployed in the field. It's really incredible. Then you also can choose a different range of sensors using the WisBlock sensor blocks, which are very tiny and they can even be reversed. And finally, we have WisBlock I/O, which adds many capabilities such as Modbus, 4 to 20 milliamp buses, cellular, Wi-Fi, anything you want. And here we can see the whole range of WisBlock modules, comprising the baseboard, the core module we have, all the sensor options we currently have, and all the I/O as well. However, we are always expanding this range, and we'll have many, many more blocks coming this year, both in the baseboard, microcontroller, I/O, and sensors. So WisBlock is really more than a product. It's a whole ecosystem of sensors, I/O, core modules all together, which can be mixed and matched very easily by the end users. And it's all open source. We give you all the schematics, even the core modules, which is very unique among vendors. We want support to create your own modules. We will help you certify them. We'll help develop them. And we'll also help you sell them through our web store if you wish to do so. Just get in touch. And now we reach the best part, which is the practical workshop. And now Maria will explain how you can create a very useful application using WisBlock very, very quickly. Hope you enjoy it. Thank you very much.
Hello everyone. Thanks for joining our workshop about deploying NB-IoT solutions using WisBlock hardware development platform, the ThinkStack, and UbiDots. My name is Maria, and I am part of the RAK wireless developer relation team. For a better idea about the goal of this workshop, let's first meet Pure Air System, a company with a mission to create air quality awareness through practical IoT solutions that help create safe, reliable, and enjoyable living and working environments. Pure Air System services offer ready-to-deploy hardware products together with an information platform to monitor air quality in schools, offices, gyms, hospitals, hotels, and restaurants. From sensors to data visualization, Pure Air Systems is able to deliver data to their clients in a pretty simple way. To start with our product, you just have to visit their page, order the number of devices decided, and also include some extra information in case you want to add some custom information to the devices, such as names, locations, or any additional property. A few days later, you will receive the devices along with the credential to access to your account and start sensing the environment in just a few seconds. Maybe some of you may be wondering how this company was able to integrate this whole system, and also how much time did they have to invest as well as money to get these solutions into the hands of the customer. Or maybe how many people was involved behind all the integration process. Would you believe me if I told you that just one person was in charge of the whole integration? Let's get hands-on with this workshop to build up an IoT business on your own. We will go through all the processes of creating a customized IoT application for the company Pure Air System, or yours, which will look just like this one. The requirements to make this workshop happen are a WisBlock connected box where we're going to be using just the WisBlock base, the WisBlock core, and a WisBlock sensor, the environment sensor. We need to have LoRaWAN gateway already deployed in our Stack account. We have to create, of course, a Stack account in case we already don't have it, as well as a NB-IoT account. These are the steps that we're going to be covering through this workshop. First, we're going to start with the Stack setup. Then we're going to jump with integration with WisBlock to finally create some custom applications and user management on the platform. Finally, we're going to set up our WisBlock to get started in sensing the environment. But before getting down to the final solution, we must understand first the basic workflow of a LoRaWAN connected IoT application. First, LoRaWAN devices must be transmitting data over a gateway to the Stack. With our devices already transmitting data, we must use a payload formatter to translate the incoming data from the sensors to a JSON payload. Then, to integrate our devices with a third-party platform such as WisBlock, we have to create a webhook. To finish, we have to create our own custom API using NB functions to finally report the data in our WisBlock accounts where it can be visualized by our customers. So let's jump to the first step. Following the step just mentioned, and also with the purpose of making a real example, we're going to use a couple of WisBlocks plus an environment sensor attached to it as LoRaWAN devices. The environment sensor is capable to measure temperature, humidity, pressure, and air quality index, which is a really good candidate to deploy Pure Air System solutions. To start, first, we need to register our end devices within an application in the Stack. This can be done in two ways: manually directly on the platform, or you can just import an importable JSON file to create multiple devices at the same time, which is what we're going to be presenting today. If we customize the importable JSON file for the WisBlock, this will be look just like this one. First, we have to set up the device ID, which the device ID that is desired for all the devices to be registered. It's important to maintain the compatibility and the order with all the devices that you're going to be registered. For example, I am assigning the same device ID and I'm just replacing the serial number that I am attaching to it. With it, I can keep the number of devices that I have been deploying for this application. Then I need to assign the device credentials for each of the devices, which is the device LY, that's referred to the unique identifier of your end device, the join LY, which identifies the owner of the end device, and the app key. Also, you have to set a name and a description to each of the devices that you're going to be creating, as well as the frequency plan ID. Also, keep in mind that the parameters that you need to be able to register the WisBlock as a node are the LoRaWAN version, that is the MAC 1.0.2 version, and also the PHY version that's referred to the revision 2. LoRa concentrators and gateways are the agents that allow A-nodes devices to transmit data to the cloud. In this session, we'll be not demonstrating how to set up your gateways. However, feel free to explore our wide variety of reliable and affordable gateways either for small or industrial scale applications on our booth. Moving forward to the payload formatter, this is the way how we're going to translate our WisBlock environmental data to a human readable format. We have the encoded data coming from the end devices, passing into a decoder function, and ultimately we get a JSON key value object. Now, taking as reference the real payload, we can see that the data frame sent by our WisBlock is a 13 bytes data frame distributed in 5 variables. A marker type for identify the data type. Then we have the temperature, humidity, barometric pressure, and gas resistant values. Each of them consisting of a different number of bytes, where every value is most significant bit first. As you can notice, the frame is split in the following format. Temperature is sent as 2 bytes, humidity is sent as 2 bytes, barometric is sent as 4 bytes, as well as gas resistance. Under such premises, a JavaScript decoder for the WisBlock environmental device data will look just like this one. As you can notice, we have a decoded JSON dictionary variable where we're going to store our variable's value, alongside the data decoding functions using bitwise operations, where at the same time fill up the JSON with the results decoded. In the end, the payload formatter will return an UBIDOT's comparable JSON. So far, we have been seeing how to integrate and decode WisBlock environmental data with the ThingStack using payload formatters. Now, let's go to the ThingStack interface and see all this integration in action. So to start, we're going to refer to the ThingStack account, select Go to Applications, and create an application if you don't have it. In my case, I already have it pre-created. Here, since I am looking to create multiple devices at the same time, I'm going to import the device JSON file. So I'm going to click Import End Devices. Then I'm going to select the format, which is the ThingStack JSON, and select the file that I already have pre-created. I click on the button, then select my file and press open. Then just press create end devices and wait until the operation finish its progress. This could just took a couple of seconds. Then click on proceed and you're ready to go. This is how easy is how to create your devices in the ThingStack account. So now that we already have our devices created, we have to decode the data that is going to be sent through these devices. For this, we're going to the payload formatter option, then we're going to select the subcategory uplink, and we're going to select JavaScript as formatter type. We're going to erase the one that comes with it, and we're going to place the payload formatter required for this solution, which is the one that I just showed you. Then just click on Save Changes, and here you will see how your payload formatter has been updated. That's all. Super simple, right? So let's jump again to our presentation. Now, next step, the ThingStack and UBIDOT's integration. Basically, to communicate with our UBIDOT's account, we need to configure a webhook in the ThingStack. To do this, an HTTP request will be executed to exchange data to a client with a client and a server, which in this case, the ThingStack is the client and UBIDOT's refers to the server. So to be able to exchange this data and at the same time manipulate both incoming and outgoing data, we have to use an UBI function, which is a module offered by UBIDOT, which basically is a function as a service module where we can call and create our own APIs using Python or Node.js. Without further ado, let's go back to the ThingStack as well as to Ubidot's platform to configure this integration process. So now here we go to the integration tab, then select the subcategory webhook and click on add webhook. Here we select the Ubidot's template. We assign an ID for it. This can be environment monitoring. Then we have to assign the Ubidot's username of our account. In my case, it's Rackstars. And also we have to assign the Ubi function name. Well, but we don't have it yet. So let's jump to our Ubidot's account. Here, under the device tab, we have to go to the function option. To create a new function, it's pretty simple. Just click on the plus icon. Then we have to assign a name to it. Let's just add WisBlock environment monitoring. Then we have to select post as method, and we're going to keep Node.js as runtime. Just remove the code that is provided by default under the Ubi function module and place the code that we require for this integration. This code provides two functions, a main function and a second function that is in charge of posting the data that is going to be received to your Ubidot's account, and the main function is basically in charge of receiving the arguments that are being sent through the webhook, and then we have to parse the incoming data in order to just send the payload decoded through our devices in Ubidot, as well as referring them to the device ID which is sending the data, right? So after placing the code, we have to assign our Ubidot token in order to be able to communicate with our Ubidot account. So just click on your username icon, then click on API credentials and click on copy in the icon copy of the default token. Place it under the Ubi token variable and then press make it live, then continue, then OK, and you are ready to go. As you can notice, the HTTPS endpoint URL was automatically filled up as soon as we press the make it live button. This is the one that is going to be then configured by default through the template that Ubidot already have pre-built in the thing itself, but we don't have to care about that. We just have to care about the name, and we're going to place it under the Ubi function name. But let's keep in mind that we have to replace all the capital case that we have under the name with lowercase letters, and also we have to replace the backspace with dashes. So let's make the changes required, and that's it. Other tip and trick can be just going to the HTTPS endpoint URL and copy just the last part of it. With this way, you can avoid here, just copy and here paste it. Here you can avoid any further issue in the integration. Just click on create Ubidot's webhook and you are ready to go. So let's go back to our presentation. Now it's time to the third step, Ubidot's application setup. As you can see on the left side, we have the common application that Ubidot offers to their user. We can see their login page as well as their dashboard view. And on the right side, we can see the application that Pure Air System offers to their clients, which is completely different that we can see on the left side. So the end customers that Pure Air System have are going to see the new platform, not the Ubidot platform. But let's say that one of their Pure Air System clients want to also have their own custom application. You can do that for them. You can just add them an extra fee in their monthly payment, and you can create an application just for their devices. So if you want to create an application just like this one, and also to be able to manage hundreds of devices with just a couple of clicks, I highly recommend you to follow the model, to follow and explore the models that I'm going to be sharing with you today. First, we have the device type model, which basically allows you to automate the onboarding process event by not only just one device. It allows you to do it for thousands of devices. So you are able to configure variables properties. You are able to configure their appearance either for variables or devices, and other configurations as well. So it's pretty. It is a key to use device type if you are going to handle hundreds of devices, because you can have the control of all of them with just one click. And also, then when you create a device type, you can also create hundreds of devices using the device bulk feature creation, in order to create hundreds of devices, taking the configurations that you previously made on the device type. The other model to keep in mind is device group, which allows devices to perform operations, including, for example, adding and moving devices to an organization, or create a global event across an entire device network, which facilitates the management and allows you to save time while attempting to perform changes under hundreds of devices by just a couple of clicks, which is awesome. Then there is the dashboard setup, which allows you to understand the data, and also to control the devices remotely for any IoT solution. There are some cool features about Widget's dashboard, because they allows you to create a static dashboard and dynamic dashboard. And the difference between them is that one is totally static, as its name refers to it, and another is dynamic, because it allows you to have like a template dashboard where you can then exchange between devices that are associated to a device group or a device type. So basically, you can have like a main dashboard and then change among all of the devices. I will share you in a bit more about it. Then you have the event setup, which is to manage and trigger alerts and event based on the data captured from your sensors, and also to take action and trigger other variables, such as let's say controlling something. If my temperature is more than 30 degrees Celsius, trigger the fan variable to 1 to activate it, and send that as a downlink message, and then activate my fan remotely, which is pretty awesome. Then organization management basically allows you to segmentate multiple customers and create, let's say, any subdivision of entity resources within account. Basically, an organization can be used to create different customers, to manage different customers, or let's say different departments of a business, or any other group of user dashboard and events. You are entirely free to manage it as it is needed, based on the application you are trying to achieve within the Widget's platform. So it's pretty simple to set up. However, if you want to get more details on this, I'm going to be providing a step-by-step guide, providing all the things that you have to do in order to achieve what I'm going to show you right now. So I'm going to jump once again to my Widget's account, and here, as you can see, I already connect all my WisBlock. I have all of them here next to me. I have 1, 2, 3, 4, and the prototype one, which I love it. This acrylic case that we provide in our store to get handy developments, like for your workbench. It's pretty cool. So basically, here all the sensors are already sending data, each of them with their custom units and as well their location. Then if we refer to the dashboard section, we can see that the devices are sending data right now. These variables are not filling information. Maybe it's going to take a couple of seconds. But what I wanted to show you about these is that they have the dynamic dashboard feature that allows you to exchange between the devices that you have registered in the same organization in a pretty easy way, and it's going to keep the same template that you have for your dashboard, which is awesome. Then we have the organization management that I just shared you, but I'm not going to get deep on that. But what I wanted to show you is the application side. So then here you can see that I have two applications. I have the Air Pure System one and the Gold Scheme one because I previously created one. But do you remember that I mentioned that once your devices have been sent to you, like when Air Pure Systems send you the package with all the devices that you order, you will be received the box alongside the credentials to access to your account and start monitoring your data. Cool. So I'm going to jump on that. So I'm going to enter the organization. Then I'm going to go to the Goldstein application. And since I am the manager of the application, I want to access and have like all the permissions to control the end application under the custom branded application. So I'm going to generate like a magic link to access to that application. To do that, it's pretty simple. I'm going to press the login as a user icon, and I'm going to use the magic link option. Then I'm going to select the organization that I want to refer to it, and I'm going to create the magic link. This magic link can be just shared, and you can send it to your customers in that box, or also you can print this QR code and give them access automatically. Then you can also give them the option to ask for a new password when they are logging for the first time, and also you can assign an expiring link for this session. But just to show you quickly, I'm going to scan this QR code quickly with my phone and show you what I get. Here it's automatically open to a new website, and here we have the application presented in the website, which is pretty awesome. And here we have it. So that's all for the widgets and the thing stack setup. And now I'm going to leave you with Jose, who will be explaining how to get started with your WisBlock pretty easily in just a couple of minutes.
Hello, everyone. I hope you enjoyed the excellent presentation from Maria. So now let's move to the kind of hands-on stage. So I have here the WisBlock. It's as you can see, it's very tiny board. It has all the slots there for the sensors as well as the I/O, and then so you get two sensor blocks there, and then you get two on the back as well. So you have 4 slots for sensors. The sensors are really tiny, so I'll show it here. They're like fingernail size, and they go into the slot. So I'll just move here my camera so you can see it better. Let's see if this works.
Sorry.
Yep.
Okay.
You can see it? Good. So I'll take my screwdriver. This is the screwdriver which comes with the WisBlock kit. I'll take some very tiny screws. I don't know if you can see them. fortunately, the screwdriver is magnetic. So I'll get that sorted, and then I'll take the little tiny WisBlock sensor, just attach that to the board until I hear the famous click. So I just need to position this properly. It's always harder on video. So I look for the alignment. There's a screw hole there, so I look for that alignment. It does click now. So I'll just screw it down so it's secure. Now the great thing about the WisBlock sensors is that they are reversible. So I could just reverse the sensor block and it will still work. There's no problem with that. Okay, so I've got my BME 680 sensor. This is the sensor we're using for the workshop. You can obviously have other sensors. So here I've got the Modbus interface, for example, which will go on the WisIO block, but I'm not using that now. So now that it's ready, I just need to connect it to USB. So the board can be powered from USB. It can be powered from a LiPo battery, and it can also be powered from solar. So the solar will charge the LiPo battery. So I've got my trusty USB. I always use a USB isolator just for safety. I don't want to damage my computer. So I just have that there, but it's a simple USB too. I'll just connect the port and hopefully we'll see some light as LEDs. Ooh. Yeah. Okay, got some. I'll tweak the focus a little bit. You can see 3 LEDs there. Focusing. Sorry, I'm getting used to this overhead setup. Yep. So I've got the BME sensor there, and the board is now powered. Okay. So let's move to maybe the Arduino side. Now, can I share my screen? Not sure. Can I share my screen? Do you know, Maria? Do you know how to share it?
I write down. There is like an screen session, like an screen icon. I think right there you can share your screen.
Oh, I see it. Yeah.
Yeah.
Okay.
Cool.
Good. I'll do it now.
Here,
okay.
as you also, here is the whistle with the battery, and now here we are. Yeah.
So we've got Arduino there. Okay. I'll let me just go through the explanation first. So I'll share my browser screen.
Are you sharing right now?
Should be coming up now.
Perfect.
Yep. Okay. So WisBlock, we have a great documentation center at wisblock.io. But everything in there, and the button you need is the getting started with WisBlock. We have all this explanation. And then you get to the nice side, which is the kickstart. Everyone likes getting started very quickly. So let's look at the setup for the Arduino IDE. And this is very simple. So it only involves writing this part, so adding the additional board URL to your Arduino setup. And then that's it. You'll be set. So I'll show my Arduino screen again so you can see how that works. Okay. Right, so I've got it here. And you can see on the bottom right corner that it says WisBlock Core RAK 4631. So this is the right module. If it's not the right module, you can set it on the menu. So then I can open an example. And I'll use we have examples for most of our sensors already. So I'll use the BME environment sensor, the basic script. And this is the wrong window. Maybe I'll just share my screen. It's easier. Let me share my whole. Oh, okay, I can share it. Good. Okay. Oh. Now we get this effect. So I'll close this down. And we have got the thing. So if you miss the best part, so you need to set the board here. Once you've got that BSP set up, the board will appear under RAK wireless and RF modules, and you just select the 4631. You've got to select the right port. In this case, I think it's this one. So I've got my example loaded here, and I'll just press upload. And it failed. Oh. I don't have the library.
The best opportunity to just click on the link instead of looking for it, and people can see how easily they can install the library. I received some question about like installing the libraries, but this is a really amazing feature that is provided like in our libraries, that you just click on the link and you will be automatically redirected to the library manager module, where you can just click install and you will ready to go.
And yeah, like Maria said, it's magic. Found it. I'll just press install. Okay, close. And now it should work. Fingers crossed. Tongue at the right angle, and always takes longer in live demos, of course. But yeah, it's compiled now. It's uploading to the board. So the board comes pre-flashed with the bootloader. This is the UF2 bootloader. Very standard, so you can use other software like from Adafruit and other sources. And now it's complaining that it's not in the FU mode. Let's try that again. Okay, now it should work. I think it was running something else. Yeah, it's programmed. And now I can go into my serial monitor. And yep, I'm getting readings now. So this is just showing the local readings, of course. If you follow Maria's workshop example, then you can send it to UB.dots through LoRa and TTN. So I think this shows really how simple it is, right? What do you think, Maria?
Yeah, it's perfect. Like the difference between like this example that Jose is sharing today is that it's not sending the data to LoRa, but you can find that code in the repo that I just shared through the comment section. And then the only difference that you will see on the console log is that you will see the status when the device is trying to join the network, and then as soon as it's joined, it starts presenting the reading. And then if you're using the same code that shared on the repository, and also you have the OLED display, you will be able to have a nice setup just like this one, in case you want. As you can see, this is with battery, no connections anywhere, and you will ready to go. I think this is everything for today's workshop. I don't know, also, if you want to add something else. And anyone who is connected, if you have any question, feel free to ask them. This is the time.
Yeah, let's move to questions.
Okay, we have one here, Maria Jose. WisBlock works well with POCs and prototyping. Do you provide some options when you want to scale? Jose, you want to help me with this one?
Yes, of course we do. So this is all standard components. We make them at very high scales, thousands. So we have no problem doing that. So the idea is that you just select the blocks you need for your application once you've determined what they are, and you just tell RAK, I want like 1,000 of these, and RAK will make them. We'll assemble them as you want, and we'll flash them as well as required.
I think like this is something that is pretty cool about the WisBlock, because at the end I think you can have like a nice toolbox for your prototyping things, and then when you're ready to go, you just go and contact RAK and say, hey, I need the WisBlock with this number of sensor attached to it, and you can go easily to production. For example, I have this like plastic box with all my WisBlock nodes, as well as some additional antennas and cables, as well as connector in case that I need to do something quickly. And then if I need something to production, I just inform RAK and you're ready to deploy your IoT devices. Another question, do you have any support for going outdoor with those devices, like waterproof cases?
Yeah, we've got some waterproof cases. Actually, I've got one here. I'll just.
Yeah, I have one right there.
So yeah, this is our solar box, fully IP67 rated, and it takes WisBlock inside. It's not the prettiest thing, so we are working on some nicer boxes, but this already does the job. I've got some of this outside for over a year now because we've been working on this for a long time. And yeah, it's no problem. And the solar keeps everything topped up, so you don't spend a lot of. The battery doesn't really run down a lot. That really helps. Yeah,
Super.
no worries about mutiness. Yes, exactly. It's already better than like shipping like a breadboard to a client. So.
And also, there is a good thing that Jose just mentioned. Well, he is a question, but answered with it. They are open source, right? Where should I start to build my own blocks? This is something that is important to highlight. And it is that the WisBlock project is an open source project, and you can find all the hardware documentations as well as the software documentation available on our documentation center. Also, in that link, in that repo that I just shared, you will find additional contribution from our Rackster. You can find enclosures for to be printed, and you can just make your prototypes at home. You can find different kind of enclosures right there, like for outdoor environment, but you need to have like let's say a PLE that is affordable for outdoor environments, and also like for indoor cases. Actually, I have one printed right here. Let me quickly show you to you. This is like one of our contributor share. So basically, this is like similar to the indoor case that we provide in our store, but I just printed on my 3D printer, and I can just put my battery, put my WisBlock, and I am ready to go. It's pretty nice. And also, you can create your own hardware modules, which is awesome. Like, let's say that you want to go to create an agriculture application, and you need like a ESD I12 is a module to connect your agriculture sensors. You can simply do it as one of our contributors already did it and shared it with our community. So if you need this module that is not created by us, you can just go to the awesome WisBlock repo and download the piece. Then just go to ask to the PCB manufacturer to create it, and you can find the connector, those small connectors that we provide for the WisBlock in our store, and you are ready to go with your own WisBlock model.
Yep.
It's really good. Yeah. So yeah, I think that is all. We haven't received another question so far.
Yeah, KiCad. We are. Do we have KiCad yet, Maria? I think we are working on that, right?
Yeah,
we'll have that soon.
We have that. Yeah.
We have Eagle now. Yeah. We have the Eagle templates, but we'll have KiCad, of course, very soon.
Yeah.
Good. Thank you very much.
I think this is all for the session.
Yeah.
No, thanks, guys, for joining the session. I hope you enjoyed as I did and Jose as well. And let us know if you have any additional question. You can reach out to us in our booth. We are going to be handling some Q&A questions in our booth to talk a little bit deeper about the WisBlock.
Mhm.
And yeah, feel free to reach out to us in our booth. And also, we are giving away a WisBlock connected box in our booth. So feel free to fill out the survey that we have at the end of our booth. We want to also know more about you, about the projects you're working on, to see how we can help you guys. And yeah, that's all. Thanks for joining and see you around. I hope you keep enjoying the conference.
Thank you.
Bye
Bye
bye.
bye.